Okay, so solving equations. So we're going to have 3 videos for this part. Rational expression, like I said, is just a fraction that contains variables. All right, so we're going to have a couple different types. So the first type, I'm going to write it as types here. So fraction equals a number. Okay, so on one side of the equal sign, because remember these are all solving for x, so on one side of the equal sign is going to be a fraction. It could just be numbers or it could have variables in it. And the other side is just going to be a single number, and I'm not even going to put it as a fraction on the other side yet. So an example of this would be okay, so we've got a rational expression on one side and a number on the other side. So we're just going to practice a few of these because there's different things to look at in this type. So there are more steps with a fraction. So the first thing we need to do is find the domain. So I mentioned domain before when we talked about rational functions the first time, and now we're going to mention it again. So this time what we're going to do is talk about the domain a little bit more. Domain are the x values that work. Now, we don't know what they are right now, and in fact, that's what we're looking for, is what x value works in this, and that we can plug in and makes both sides equal to 2, right? That's actually what we're looking for. But when we talk about domain in a fraction, we're talking about the numbers that don't work. So even though the technical definition of a domain says what x values work, you're really not looking for that at all. You're looking for what values don't work. So what values of x can we not plug in? So with a fraction, how do we know what numbers we can't plug in? Exactly. Whatever makes the bottom equal 0. So the bottom of a fraction, or the denominator, cannot equal 0. Do you agree with that? Because we can't divide by 0 or be undefined. So you take the bottom, the denominator, set it equal to 0, and solve for x. We get -1. So what does that mean, x equals -1? That's the number that if you plugged it into this whole thing, you would end up with a 0 on the bottom and you'd have to write undefined. Does that make sense? So that's the number that doesn't work. So here, before we start, we could say that the domain is, so this is the notation. Okay, so what does all this mean? So these are called set brackets. Okay, they actually have a meaning, and round brackets are ordered brackets. Anything you put in a round bracket, like a point that you plot on a graph, has to be in a certain order, x and then y. A round bracket means you can't change what's in it. A curly bracket means whatever numbers you put in it, you can put them in any order you want. That's called a set bracket. So here we don't have more than one number, we're just saying one thing, and that is that x, this means all x. That line you would read as such that, and here's the condition, x is not equal to 0, and, of course we know this one, x is an element of real numbers. Oops, real numbers. Okay, so when you actually look at a domain, you read all of that. You say, the set of all x, such that x is not equal to -1, and x is an element of real numbers. So you can think of and as like but, x is an element of real numbers, so it's not -1, but it can be anything else. Okay, so that's what it's saying. Now, we know this is not actually true for this question. We can't just plug in a random x and it will work. There is probably a specific x that works. But we have to, before we start, look at the x's that don't work. Okay, and I'll show you an example of why that's important later, not in the first one. It's not going to appear here. So let's just rewrite the question. So 3 minus 2x over 5x plus 5 equals 2. Okay, so all we've done so far, we said, okay, what x doesn't work? -1, you have that in your mind or written off to the side. It's not even part of the question, but you need to remember it when you get your answer. If we get an answer later that says x is -1, we say, oh no, we can't use that, there's no solution. That's the idea. Okay, so how do you solve this type of expression? So we have a fraction a over b equals a number, c. What do you do to both sides? Multiply both sides by b. These will cancel, and you'll have a equals c times b. And it's no longer a fraction. We did the same thing already when we saw things like 4x equals 8. We divide both sides by 4. Dividing both sides by 4 is the same as multiplying both sides by 1/4. That's the same thing. We don't usually like to see it as a fraction. Instead, we like to think of it as a divide, but anytime we divide, it is a fraction. Right? So here, we're going to start with a fraction, and then it's gone. Now, instead of multiplying both sides by b, after we've done that a bunch of times in school, what do they then tell you to do instead? Any ideas? Someone mentioned it to me, like in one of the first classes, and they were talking about something else, but this is what I thought they were talking about. What's that?
Cross multiply.
Yeah, cross multiply. And that is allowed, so you would take cross multiply. Cross multiplying happens only across an equal sign. That's the only time in math you can cross multiply, is if there's an equal sign and a fraction. So to cross multiply, anything that's in the denominator can multiply on the top of the other side. So here, all that the difference would be is that you don't see this b on this side. You just take it and multiply it on the other side. So there it is. So here we would have 3 minus 2x is equal to 2 onto 5x plus 5. And then we do the same thing we did before, except when you get your answer, you have to make sure that it's not -1. So here, 3 minus 2, leave the minus 2x on the left. Oh no, sorry. 3 minus 2x, there's a bracket here, so multiply this out. 10x, 2 times 5 is 10. All right, now rearrange. So we're going to leave the 2x minus 2x, move the 10 over, minus 10. Leave the 10 on this side and move the 3 over. That's a positive 3, so it would be negative on this side. Divide both sides by -12. And remember, I said a couple times in class that the minus sign on a fraction can be on the bottom, the top, or the middle. It doesn't matter. If you said your answer was 7 divided by -12, that's cool. Normally, you'd put it on top or in front, but it doesn't matter. It's not wrong either way. Now, is that answer -1? No, so we're okay. So that's the solution. Now, if we had ended up with a -1, then we would say, that's inadmissible. We'll write it down when we do one. Inadmissible means it's an answer that doesn't actually end up working. So inadmissible means throw it out, and then there's no solution. Lots of math words that maybe you missed along the way that mean different things. Okay, so let's do one more example for today, and then we'll do this a little more of these, adding a few layers to it next class. Okay, so here, So let's look at the domain first. So all you do, I wrote a lot in the last question, but all you do is take the bottom, set it equal to 0, and you solve for x. So this will be 2x equals negative 4, x equals negative 2. So you say, okay, x cannot be negative 2. I'll remember that later. All right, so what happens when we cross multiply here? We're going to take the bottom, multiply it over with the top. So 5x plus 10 is equal to 0 onto 2x plus 4. What's 0 times anything? 0. I wouldn't even write it, because what happens a lot of times, I would just, if you see that it's times 0, just write 0 on that side automatically, if you can remember to. When people write this down, sometimes they end up treating it like a 1 for some reason. You know better, but you end up doing it by mistake. So now that's gone. We just move the 10 over. So 5x equals negative 10. Divide both sides by 5. X equals negative 2. Oh, no!
Oh.
Right, you see? So this x can't be 2, so we say this is inadmissible. Therefore, no solution. So the word inadmissible is an answer that we throw away. Okay? So these inadmissible answers actually, I just wrote answer that we throw away. Inadmissible answers happen all the time with radicals. Because a radical, what can you not have under a square root? Any negative number. So there's lots of possible answers that don't end up working. So we end up throwing out answers all the time that can't work in the original equation. So we'll see that next class, because we're going to finish with fractions. We're going to add common denominator to this. Then we'll do radicals. Okay?